Hi students, now I'm going to teach a topic of Introduction to Power Measurement. Let's start the topic. So measurement of power. Power measurement is of two types, DC power measurement and AC power measurement. In DC power measurement, there is no concept of power factor. So we go by P equal to VI. And methods to measure voltmeter, ammeter method and ammeter, voltmeter method. Second, AC power measurement P equal to VI cos phi. See, in AC power measurement, concept of power factor comes. Method to measure dynamometer type wattmeter. Dynamometer type wattmeter. Methods to measure dynamometer type wattmeter. So let's see first DC power measurement. So DC power measurement. In order to measure DC power, supply should be a DC source and load must be a resistive load. So I'm applying this point here. See, supply should be a DC source and load must be a resistive load. And why I named here voltmeter ammeter method? Why I named here voltmeter ammeter method? Because initially I am placing voltmeter here. And next I am placing ammeter here. So voltmeter ammeter method. Why I am naming it as voltmeter ammeter? Initially I am placing voltmeter and next I am placing ammeter, then the resistive load. So observe here, voltmeter reads the voltage across the ammeter and voltage across the load. I'm repeating again, voltmeter measures the voltage across ammeter and voltage across load. Whereas ammeter, current through ammeter and current through load both are same, they are connected in series. So this current is same, this current is same, this current is same, this current is same. So what? So current through the ammeter is same as current through the load. The same points I am replacing here. What is measured power? P equal to VI. A generalized formula in DC power is P equal to VI. P is equal to VI. So what is voltmeter reading? What is voltmeter reading? VL plus VA. Why? See, voltmeter reads voltage. VL is voltage across the load and voltage across ammeter. VL plus VA into what is ammeter reading? What is ammeter reading into IL? Ammeter reading into IL. So that VL IL plus VA IL. Accepted. The next step. What is VL IL? What is VL IL? What is VL IL? Is a true power. Voltage across the load and current through the load is called as a true power. So VL IL plus VA IL. True power. So measured power is equal to true power plus what is IL square RL? What is power loss across ammeter? IL square RL. Is something lost now? Is loss. IL square RL is loss. So this loss is due to what? Ammeter. This loss is because VA IL is what? VAL is voltage drop across the ammeter. Power loss across ammeter. Power across ammeter na VAL. So IL square RL is power loss. Note from this equation, please try to observe from this equation. From this equation, please try to observe from this equation. Measured power greater than true power. Measured power greater than true power. Error. This is error now. Which part is error? This part is error. This part is error. So error due to ammeter only. Error due to ammeter only. It is used for the measurement of high resistance and low load current. Why? Why? Why it is used for the measurement of high resistance and low load current? So when resistance is high, current will be low. Because I is equal to V by R. When resistance is high, current will be low. Okay, let's check why. So measured resistance R measured is equal to R equal to V by I now. How we got R is equal to V by I. Same points I kept here. R is equal to V by I. So measured voltmeter reading by ammeter reading. What voltmeter reads? What voltmeter reads? Voltage across ammeter and voltage across load. Voltage across ammeter and voltage across load. What ammeter reads? Current through the load. What ammeter reads? Current through the load. So current through the load. So substitute here R measured is equal to, substitute this equation in this, VL plus VA by IL. VL plus, substitute in this. Just substitute these values in this equation. Substitute these values in the above equation, VL. And R true, what is R true? Voltage across the load and current through the load is called as a R true. So R measured from this. Compare these two, please. Compare these two. Compare R measured and R true. Compare R measured and R true. Which is higher? R measured greater than R true. R measured greater than R true. So whenever resistance is high, current is low. So it is used for the measurement of high resistance. It is used for the measurement of high resistance and low load current. Okay, na? Then next, let's go for our next method. Ammeter voltmeter method. Ammeter voltmeter method. Why I named ammeter voltmeter method? Because initially I placed ammeter, next I placed voltmeter. Initially I placed ammeter, next I placed voltmeter, then resistive load. So then next step, I gave here DC supply, the same resistive load. Here ammeter measures, carries the current of voltmeter, current passing through the voltmeter and current passing through the load. That is what I kept here. Please observe this. Current passing through the ammeter is equal to current passing through voltmeter plus current passing through the load. Whereas voltmeter measures the voltage across load only, because what is this? Voltmeter measures voltage across load. Voltmeter measures voltage across the load. Voltmeter measures voltage across the load. So the next measured power, the same formula. P is equal to, since P is equal to VI. Since P is equal to VI. So VL into IL plus IV. How I got voltmeter rates? Voltmeter reads voltage across the load. And ammeter reading is what ammeter reads? Ammeter is current through the voltmeter and current through the load. So current through the load and current through the voltmeter. So split them VLIL plus VLIV. Again, this is what? True power. VLIL is what? True power. VLIL is true power. The left node is what? Loss. This is loss. Loss through to what? What is VLIV? Voltage across the load. And IV, current through the voltmeter. So this is due to what this is called as, this is error. This is error. So what error due to? So VLIV is power loss, or we say it as error. So note, from this equation, please, from this equation, measured power greater than true power. Measured power greater than true power. Error due to voltmeter only. Error due to voltmeter only. It is used for measurement of low resistance and high load current. If resistance is low, the same formula I is equal to V by R. If resistance is low, current is high. The same. It is used for the measurement of low resistance and high load current. Why? R measured is equal to voltmeter reading by ammeter reading. Please again try to understand the same formula. Why? R is equal to V by I. The same formula I am using here. The same formula I am using here. So voltmeter reading is equal to VL. Why voltmeter reading is equal to VL? See, voltmeter reads voltage across the load. Voltmeter reads voltage across the load. And ammeter reads current through the same voltmeter and current through the load. Same points I am substituting here. Substitute these two for equations in the above equation. Substitute this in this. So what voltmeter reads VL by IL plus IP, and R true is equal to, this is true power never change. Please, true power never change. Note, true power or true na never change. Whether we use voltmeter, ammeter method or ammeter, voltmeter method. Okay, now please try to observe here. True power in VL by IL in this method, and true power is equal to VL by IL. Please, true power is not changing. True power is not changing. See, observe. True power is not changing. It is same in both the equations, in both the methods. That is what I mentioned here. True power never change. Whether we use voltmeter, ammeter method or ammeter voltmeter method. So please compare these two equations, R measured and R true, which is higher? R true is higher. R true is higher. So whenever my true power is greater, so whenever my measured resistance is low, this measurement of low resistance. Whenever resistance is low, current is high. Whenever resistance is low, current is high. That is the reason it is used for the measurement of low resistance and high load current. So final conclusion, in both methods, what are both methods? Both methods means voltmeter, ammeter method, and ammeter, voltmeter method. Okay, now both the methods measured value greater than true value. PM greater than P true. PM greater than P true. So in both methods, error is always due to load side instrument. Means what? Both method means, say, in what voltmeter ammeter method, voltmeter ammeter method, voltmeter ammeter method. What in voltmeter ammeter method? So this is my load. So error is due to ammeter. Error is due to ammeter. Error due to ammeter. And the next in ammeter voltmeter method. In ammeter voltmeter method. Sorry, ammeter should be always connected in series. In ammeter voltmeter method. So error is due to what? Error due to voltmeter. Error due to voltmeter. So that is what we say. In both the methods, error due to load side instrument, which is towards load, which is near to load. Here, voltmeter is near to load. In this case, ammeter is near to load. That is what my point is. In both methods, error is always due to load side instrument. Thanking you.